Hello, everyone, and welcome to today's webinar, a practical guide to creating digital-ready slides. I am Marie Stone of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Leica Biosystems. To learn more, visit leicabiosystems.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I'd like to now welcome our speaker, Dr. Olga Colgan, Global Brand Strategy Director, Leica Biosystems. Olga, you may now begin your presentation.
Thank you for the introductions, and hello and thank you to everybody who has joined today. What I would like to bring us through today is to introduce the concept of digital ready slides. What exactly do we mean by that? What are the attributes associated with it? And also to provide some practical guidelines and pragmatic tips on how best to create digital ready slides. As we look at digital ready slides and creating digital ready slides, one of the questions I often get asked is, well, why now? And to do this, maybe we take a little bit of a step back and look at when artificial intelligence kind of first became recognized. And this was back in the 1950s, where the term artificial intelligence was first coined by John McCarthy et al. And looking at a branch of machine learning where a computer could emulate what a human may do in the same situation. And then we jump forward to kind of the last 2 decades and looking at the widespread adoption of digital pathology across a number of use cases, whether that's in research or clinical type applications. I'm moving exclusively away from the microscope and starting to leverage digital pathology and on-screen review of slides. And it's kind of the convergence of these two that are leading us to digital ready slides. But even then, the why now question still exists. And I refer to this sometimes as the perfect storm. And we're now at a stage where the maturity of digital pathology technology is at that stage where it is suitable for true high throughput routine usage. You also have acceptance of the usage of digital pathology by a number of the governing bodies and regulatory bodies in different regions across the world. We've also seen massive developments in the infrastructure and IT capabilities that are available, both looking at disk speeds, the widespread availability of internet connectivity and Wi-Fi, and also a huge body of evidence and proof of the value of the utilization of digital pathology. And really that puts us in a position where now we're starting to see as well the development of artificial intelligence-based tools for usage with digital pathology. And really the input to those, to any development of an artificial intelligence-based tool for pathology is going to be based on those digital pathology slides. And really that gives the whole requirement and the need for having digital ready slides. So there are some key features that digital ready slides should exhibit. And you can see them here on screen. The first is that these will scan automatically. And really this is to minimize the user intervention. And the idea here being that as you start using these routinely for high throughput, widespread scanning, you don't want to be burning 30 seconds or a minute on every slide, because the hands-on time for that just becomes paralyzing. The other piece is that you really want to make sure you capture all tissue that's on the slide. And this would include any small fragments of tissue, if there's faintly stained tissue, in particular in the case where you may have some IHC staining and there's faint expression in a fragment of tissue, you really want to make sure that that's still captured, or low cellular density tissue as well, which can sometimes be problematic. So you want to make sure that all that tissue is captured on the slide, but then also you want to make sure that it's done with the smallest possible scan area, and ideally in one focal plane. And really where this comes to is you could capture the whole slide region for every single slide, but you're going to capture an awful lot of white space at usually high resolution scanning, and that is going to firstly take longer to scan, and secondly you're going to have the larger file size and then storage requirements that are unnecessary. So these two pieces together, where you want to capture all the tissue but you want to do it in the smallest possible area, and again, if possible, in one focal plane. Because as you capture these digital pathology slides, they can be very large, depending on the magnification that you're using, depending on the size of the piece of tissue that you're capturing. But these are in the range of anywhere between 250 megabytes to a gigabyte in size, give or take. Every time you capture a Z stack, you're capturing another image, so you're multiplying then the file size across the slide. So ideally for routine usage, if you can capture at a single focal plane, that's going to be advantageous both from a scan time and a file size perspective. The final piece in the key features or the attributes of digital ready slides is to automate the data flow. And again, this is with a view to minimizing hands-on time, not sitting there doing data entry, but also to avoid manual data entry and associated error risks. As we look at bringing digital pathology into a laboratory, it's not as simple as just putting a scanner in after the cover slipping stage and taking off from them. We really need to look holistically at the complete workflow, that end-to-end workflow within the lab, and all the different steps in that tissue preparation stage that will actually impact your final slide. And how do we optimize each of these steps to create these digital ready slides? So for this, I'm going to start at embedding, and this predominantly pertains to when you're embedding multiple tissues in the one block, such as needle core biopsies, for instance. And the first piece is to cluster the samples together. And this follows some of the best practice that you would have typically anyway at embedding. But the idea being, and you can see it clearly in the cluster samples in the one on the left, samples are quite spread out. So what this is going to do is, from a scanning perspective, you're going to have a larger scan area there. So that's going to take longer to scan, and it's also going to lead to a larger file size. This, and then the version on the right, shows you if you just put those a little closer together, still with sufficient space so that they don't overlap during sectioning, and there's limited risk that would happen. But this is going to give you probably about half the scan region, and again, that's going to make you twice as fast and half the file size. The other piece when you're clustering your samples is all to align them in the same direction. And where this also gives an advantage, depending on the scanner that you're using or the type of focusing mechanism that it uses, if you can align your samples so that the focusing method or the scanning of your slides follows the direction of your tissue, you have a much higher chance that all of your tissue will be in focus. And that's because your scanner isn't going to jump from tissue into white space into tissue, and kind of mapping that microtopography of the environment. Then as we move on from embedding and into microtomy, there is a massive importance of best practice. And some of these things aren't exclusive to digital pathology or digital ready slides. However, they can be exaggerated when you move into a digital environment. Again, if you look at something like tears, they're annoying and bothersome when you're reviewing under a microscope. However, when you start to utilize digital pathology, this can cause the focusing, again, depending on the type of scanner that you're using, it can cause the focusing to jump out of focus, where in that white space it's trying to detect tissue, and maybe it'll detect a fragment that's at a different level in the microtopography and then cause some out of focus region. The very same is true for folds within tissue. And even looking at the example that we have here, that tissue is going to be 2, 3, maybe 4 times deeper in this folded region that you can see. And again, that's going to lead to out of focus regions or the necessity to then acquire in Z-stacks. As we move across then and look at contamination, and this is an example of a fungal contamination within the water bath from not changing the water frequently enough. And these little flecks of debris then that appear on the slide can be recognized by your scanner as faintly stained tissue or potentially low density tissue. And again, that's going to lead to a much greater region of interest being selected and scanned for the slide, leading to those, again, slower scan times and larger file sizes. And the same thing is true with chatter in your slides or in your tissue, very similar to the tears or the folds, which is all about that focusing mechanism and about being able to map that microtopography within your slides. So in addition to all of those kind of standard best practice pieces at Microtomy, some considerations where you may need to vary your practice when you start looking at introducing digital pathology is the section thickness. And quite often this can be a little bit thinner than the sections that are typically used. So it's typically somewhere in the region of 3 to 4 microns tends to be ideal for digital pathology, enabling you to scan in a single focal plane. And if we have a look at how this works, and you can see a kind of an overview here of an objective lens, very typical as to what you would see inside most scanners. And you'll have your layer of optimal focus, and then you'll have a depth of field. If you have thin sections, and they will have that microtopography and variability along the surface of the tissue, but if all of your tissue falls within that depth of field and we can map according to it, then there's a high chance that you will be able to capture all of your tissue in focus in a single focal plane pass. However, if your sample is thicker, then you may find there are areas where you cannot capture at a single focal plane, and then that's going to push you to a situation where you're going to need to employ Z-stacking or have out of focus regions, neither of which are optimized when you're looking to do high throughput routine scanning. The other piece to take into consideration when you look at section thickness is the impact of thickness on staining. And in the example here, I'm looking at IHC staining interpretation. And it is documented in the literature and peer-reviewed publications on showing that section thickness affects our interpretation of IHC staining, whether that is done manually or whether that's done using automated analysis techniques. And I think this even becomes more important as we start looking at either manual sharing of slides and manual review on screen with digital pathology, where you could be undercalling or overcalling your IHC staining based on the section thickness. Or indeed, as we look at the further development of tools utilizing and leveraging AI, and that standardization of your section thickness becomes even more and more important. Moving on, but still at the microtomy, is your tissue placement. So when you're actually floating your sections, you've got nice ribbons, you're floating your sections and the placement on the slide. Best rule of thumb is to place centrally. But again, this is even more exaggerated when you look at digital pathology, because most scanners will have a no scan zone towards the edges of the slide, and this no scan zone may even overlap with the edges of the cover slip. Again, it varies model to model and manufacturer to manufacturer, so it's important to know for the scanner that you're looking to use within your laboratory, what are the borders for the actual scan region, and to make sure that all of your tissue is within that scan region or that scannable region on the slide, and to make sure that you don't have situations like they're shown on the left of the slide here, where again, best practice, you don't have fragments of tissue outside of the cover slip area. All of these things, if you have your tissue misplaced on the slide, they can impact your tissue detection, your tissue focusing, and also the ability to actually capture all of that tissue in your digital slide. Moving on then away from microtomy, but onto slide labeling. And the first piece I'd like to touch on here is in relation to automatic slide identification. And I've said it previously, but the rule of thumb that I go by here is if you're looking to scan any more than 100 slides daily, you really will need to look at barcoding your slides. Digital pathology images are so large, they do require specialized image management and viewing software. And typically then you need to associate your metadata with those slides. So, where is that slide from? Which case or animal or study is it related to? And that's where integrating with your laboratory data system, whether that's your lists or your LIMS, becomes absolutely integral into having an end-to-end solution for your digital pathology. And what that will allow you to do is, based on your barcodes, automate the association of your slide data and your whole slide images, and aggregate those cases or those studies together. So to move from a situation where you are manually slide sorting into the appropriate groups or cases to something that can then be truly automated. And this is one of the areas where bringing digital pathology into a laboratory can add some extra steps to the lab, but it can also help alleviate some of those traditional steps, such as the case sorting, which can be done automatically. So there are some workflow benefits that can be realized there as well. The other piece about using barcodes or your slide labeling comes from minimizing your data error risk. And nobody wants error within their databases. So looking firstly at the manual workflow, and the slides here are supposed to represent handwritten slides. And for those of you with a very keen eye, you may notice that the slide at the back says B46H5S0, and the one at the front is B46HSS0. Or is it a 0 or is it an O? It's very difficult to tell and often impossible to distinguish with handwriting. As we move along, then this is clearly an area where you have risk. There's very much risk of, handwritten errors, but also interpreting that handwriting. Reading somebody else's handwriting can always be problematic, and it's also very time consuming compared to generating slide labels automatically. It doesn't really impact too much at the scanning stage, but the next area then where it comes is, once you have your slides scanned, how are you going to create in a manual workflow where you have handwritten slides? You're going to manually have to create that association between your digital slide coming off your scanner and your database, whatever format that might be in. And this requires significant data entry. And with any data entry, it's going to be time consuming and it's another job to be done manually. And it's also going to be inherently prone to keystroke errors. that ultimately those two pieces together then lead to potential errors within that final aggregated slide and data set that you have. However, if we look at the barcoded workflow, you have the ability to have human readable and barcoded labels as the one label. You eliminate that error that you may have with handwritten or transcription errors, and then leveraging that integration pathway with the existing information management systems, you can be assured then that the right slide is being associated with the correct data within your information management system, and that aggregation is being done automatically. So by moving to this type of scenario, you really are going to limit your risk and eliminate some of those manual workflow steps within the process. That overall give you greater confidence and security in what you're actually viewing digitally on screen, or indeed leveraging for AI or automated image analysis development. When it actually comes to the slide labeling, there are some best practices to consider with this, things to do and things to avoid. So if you have multiple overlapping labels, you can run into some difficulties or come up against some challenges. The first is that you may exceed the slide thickness tolerance. And again, this is going to be very scanner dependent, and looking at how different scanners and different models move the slide from whatever kind of either slide tray or slide carrier it has and puts it in under that objective for high resolution scanning. And there are a number of different methodologies involved, whether it's a push-pull mechanism on the slides. Some scanners have little grabbers where they pick up the slides and move them. Others put them into little clip-based slide trays for moving into that kind of under the objective for the high resolution scanning. All of them, though, have a tolerance. No matter which mechanism is employed, each of them will have a tolerance to the slide size and the slide thickness. And if you exceed this, you run the risk where slides can get jammed, which is kind of the easiest one to resolve it in a lot of cases, but still jammed slides mean it's unscheduled downtime. You're going to have to remove them similarly to the way you'd remove a paper jam in a printer. Slides may not fit in the carriers. In the worst case scenario, slides can get stuck. You may not be able to resolve it, on site. You may need to call in an engineer, or in worst case scenario, slides could get broken, leaving, obviously you're going to lose that sample, which is not a good place to be in if this is a rare or a sample where you can't go back and cut from another block, or potentially broken glass within your scanner mechanism, neither of which are positive things. The same is true for sticky overhangs. So trying to ensure that when you place your slide label on your slide, that it is fully within the boundaries of your glass slide. Because again, similarly, sticky overhangs, they can stick the slides to the moving mechanisms, to trays, and again, can result in all those problems we just discussed with broken slides, potentially broken glass, damaged slides, slides jammed in the mechanisms. So best practice is, where possible, single slide label within the boundaries of the glass slide. The next step in the process that I'd like to speak to in relation to digital ready slides is actually around the staining. And whether this is your H&E staining, your standard routine staining, special stains, IHC, or other staining modalities, moving from reading slides on a microscope to reading on screen is a paradigm shift for the reviewer, whether that's a pathologist or laboratory personnel or researchers. And by standardizing your staining, you're going to remove one of those obstacles or those pieces that need to be overcome as you're moving towards on-screen review. The other piece is that some of those added advantages of digital pathology, such as the multi-slide review options, and you can see it here on the top right-hand side, where you can pull multiple slides onto screen at the same time, potentially serial sections from the one piece of tissue, or to compare the staining and the expression profile between different groups or different study groups in a research situation. That is going to emphasize any staining variation that you may have within your tissue preparation. And you want to be able to have that confidence to say that the staining that you're looking at is true staining, and that, for instance, in the example that's shown here, that is a variation in staining, and that the tissue on the left-hand side does have a higher expression profile, and that this isn't to do with manual variation in staining, that I didn't leave it to bind as long as I needed to. And really it's that ability of digital pathology to maybe highlight and emphasize some of these items. The other piece, and you'll see it then down on the H&E slides towards the bottom of the screen, these are actually serial sections of the same tissue, cut to the same thickness and sent to different labs, asking them to just do their normal H&E staining on it. And what you'll see here is a massive variation into the color and the intensity of the staining of their H&E. And as you start looking at leveraging digital pathology, either for sharing across multiple sites where you have your tissue coming from different labs and either into a centralized or distributed review, that can highlight some of these differences and really bring them to the fore. It also potentially has that impact as you start looking at AI development and what's the variability in your input to those training sets, and what impact does it actually have then on the size of the training set that you need and the performance of your AI tools. The next piece at the staining stage is to make sure that your slides are free of any staining debris or artifacts. And the easiest and most simple way to do this is to ensure that you have the appropriate post-stain washes. And what they will do is obviously remove any residual stain if you've got any streaks of stain across your slide. Sometimes you'll get those DAB clumps, in particular if you're doing any kind of manual IHC work, or just general debris. And again, these pieces of debris can be problematic on a number of different levels when you start looking at digital pathology and scanning those slides. The first is that, and in the situation of the slide on the top here, where this piece of debris towards the left-hand side could be recognized as tissue. And again, that's going to increase then the scan area, which is going to give you a bigger file slide size and slower scanning. That's going to give you slower throughput overall. And if this is a recurring issue, it will really start to impact on that throughput of scanning within your laboratory. And it can also lead to out of focus regions, again, depending on the scanning mechanism of the instrument that you're utilizing. It can cause it to recognize maybe the debris as the tissue and set the kind of gross focusing, similar to your coarse focus on a microscope, that it would be set there, and then your actual tissue of interest may be out of focus. And it can also lead to missed tissue. Again, if you had a situation where you've got a big clump of dark debris and then you've got some faintly stained tissue, it may recognize the debris as the tissue and scan that instead of the sample of interest. And all of this can lead to numerous problems, as we've discussed. The last step then, as we move on from staining, is cover slipping. And this is the last process before either going into your microscopy based review or before scanning. And I would say if you're really looking to employ digital pathology and create digital ready slides, to give very strong consideration to automated cover slipping if it's not already employed within your laboratory. This is for a number of reasons. The first is the elimination of bubbles. Again, bubbles can be problematic when focusing where they get recognized as tissue. So if they are co-located with the tissue, similar to reviewing under a microscope, you may not be able to pull that tissue into sharp focus because of the bubble. If it is located away from the tissue, again, this can be identified as tissue and then captured within the scan region. The other piece is no excess mounting media. This is quite similar in a lot of ways to the same situation that we had with the sticky labels on the slide. And that excess mounting media has two phases. Before it's fully cured and hardened and it's in that sticky and tacky state, it then runs the risk of sticking to your moving mechanisms within the scanner, whether that's a slide tray or moving on to your scanning stage for that high resolution scanning. Sticky slides are more likely to get stuck in your instrument and lead to a number of problems and jammed slides, broken slides, glass in your scanner. The other pieces then, if that excess mounting media has hardened, again, you may have lumps of this hardened mounting media at the edges of your slide, which are going to mean that your slide exceeds or could exceed the tolerance of your scanner, again, leading to the range of problems. The other piece is to have clean, dry slides. Not all scanners keep the slides in a completely horizontal position. Some of them will tip them either at an angle or into a vertical position in some situations. So if your slides aren't fully dry and if your cover slips aren't fully dry, there is a risk that they will start to slide off and pull your tissue with them. The other piece is if you've been handling the slides between cover slipping and scanning, there's a risk of putting debris or fingerprints or glove dust on these slides. Finally, you need to make sure that your cover slip is on straight. And again, this is due to the tolerance that the different scanners will have in relation to movement of the slide or the slide trays within the scanner. So overall, and I suppose to summarize, as we look at digital ready slides or digital pathology, the adoption of digital pathology is such a multifaceted project and affects multiple stakeholders within any pathology department. And as I mentioned at the top of the presentation, it's not simply just about adding a scanner after cover slipping and adding it to your workflow. It really affects the whole laboratory workflow and requires careful consideration on taking that holistic view of slide creation to really generate those optimized digital ready slides. So with that in mind, that brings me to the end of my presentation today, and I would be very happy to take any questions that you may have. Thank you very much.
Thank you, Olga, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. Let's get started. Our first question is, do these principles apply to fluorescent slides?
Oh, well, that's a great question. I think Yes and no would be my answer on that one. I think there are some elements in relation to your tissue placement, the cover slipping, the slide labeling, some of the best practices, absolutely, that would apply. I think with fluorescent slides, often utilized more in the research and life science domains, um, and at times can be picker samples. So with fluorescence, I think you need to take into consideration what magnification you're looking at with your scanner. Um, and is it something that can be done at a single focal plane, or are you going to a high resolution scan, let's say above 40x, maybe a 60 or an 80? Some of the fluorescent scanners on the market will do, in which case you're going to have a smaller depth of field, so you may need to look at employing Z stacking with that. I think the other piece to consider with fluorescent scanning is the number of passes across the tissue as well. So you're not necessarily going to be able to capture in a single pass. Um, Again, depending on the scanner that you would be using, you may need to look at your different excitation and emission levels and the different filters. And each of those filter cubes may require a separate pass across the tissue. So maybe to summarize up, yes, a lot of the principles of digital ready slides apply, whether you're looking at a bright field or fluorescence or fish, um, but you may need to tweak some of them to your own specific needs.
All right, thank you. Next question. What about fixed sections or cytology preparations? How can these be handled?
Yeah, and another great question, and one that's quite similar in a lot of ways. I think if your sections are inherently thick and you don't have the option to cut thinner sections because of what you're looking at in your tissue or your sample, then if they are inherently thick, you are going to have to consider Z stacking to be able to capture all of those focal planes and to kind of maximize what you get out of that tissue or out of that slide. Similarly for cytology, and again, that the majority of scanners on the market today are optimized for use with tissue. So if anybody's considering using with cytology preparations, I would always recommend firstly check with the manufacturer and see if the scanner is suitable for cytology preparations. And then the second would be to actually, when you get somebody in or when you're looking at a demonstration of these units, make sure you're scanning your own slides and samples that are representative of your lab output and your kind of typical usage or typical slides that you would create. It's never any harm to throw in a worst of worst type preparation to see, how the scanner can cope with the, worst type of slide that maybe comes out of your lab. Um, but I think have standard ones and test the scanner with your own samples.
All right, thank you. Next question. Is color standardization really important? Don't pathologists just naturally adjust for differences in staining, such as H&E?
Yes, I think that this is a very interesting one and one that could be lead us to hours of debate around the topic. And yes, the human eye and pathologists and reviewers will naturally kind of white balance or adjust their eye for changes in staining. We're not as sensitive to it when you're looking down a microscope because you look at each of the slides in individuality. You're just looking at one H&E, and then if the next one that you put on your microscope is 5 or 10% difference in the staining, you're probably not going to observe that or kind of realize it at that kind of point under the microscope. However, it's some of the power of digital pathology and being able to put those slides side by side in a viewer that really starts to highlight where you will have differences or drift in your staining. And really, where this kind of has a two-part play out to it. The first is when you're looking at a manual on-screen review and utilizing digital pathology. As I say, that side by side can highlight differences. Also, if you're receiving in slides from multiple laboratory locations, let's say you're working in some kind of networked environment with multiple labs, um, finishing or sending slides in, then that can highlight differences in the H&E or in other staining between the labs. And then you have a situation as a reviewer where you're looking at these slides and going, well, are these differences in the tissue or are these differences in the staining? And as I mentioned, I think in the presentation, moving from microscope review to on-screen review is a complete paradigm shift. Um, so the more barriers or irregularities that we can remove and the more we can move towards standardization, it makes that much easier from a manual perspective. As I said, it's kind of a two-part one though, because the other point where this really comes into play is as you start looking at the development of automated analysis tools or AI-based tools. And really then when you start looking at color and color standardization, without color standardization or staining standardization in your slides, you're bringing another variable into the mix. And it's not to say that this can't be overcome, but if the opportunity is there as best practice to standardize as much as possible for that input into your AI training set and development, then you're just removing another potential source of error. I hope that covers the question, but please feel free to pop another question in the Q&A box if that doesn't fully answer what you were looking to cover there.
All right, great. Thank you. Our next question is, can the attributes of digital ready slides be universally standardized and a worldwide available digital slide biobank, perhaps in the manner of whole genome sequence, be made for eventual worldwide universal referencing?
Wow, that's a good one and would be a fantastic project. Um, Again, this is a little bit of a depends. I think can the attributes of digital ready slides be applied universally? Theoretically, yes. But again, with something like this, it depends if you are looking at doing something prospectively or retrospectively. So if these slides are already created, then obviously you've very limited input as to what you can do with them, other than scan them in their current state. You could, of course, look at a situation where you're taking new sections from blocks and creating slides from the outset. And I think in that scenario, then you could kind of almost have entry criteria with your slide submission sites, that they would standardize to a range of attributes across the slides. So I think, as I say, maybe dependent on the actual study, and how it's going to be done prospective or retrospectively, and the capabilities of the sites that would be feeding into it. I do know there's a project running in the UK, between Genomics England and the National Pathology Imaging Cooperative, who are looking at something like this. I don't have it to hand, but I know there was a press release on this in the last couple of weeks. And so that might be one to look up if you're interested in this topic.
Excellent. Thank you. Our next question is, clustering samples. Does that mean we need to limit the number of levels that are placed on a slide? GI biopsies in our lab typically have 2 levels with 2 sections of each level on a slide, so 4 total sections on a slide.
The quick answer is no. You don't need to limit the number of levels that are placed on a slide. And if this is a slide preparation that is standard for your lab, and that's your
All right. Thank you.
Yeah, no, I'm still
Oh,
here.
sorry. You cut out. I'm sorry.
No, it was me. It was my computer just did something terribly funny there.
Okay.
Apologies, but no, you don't need to limit of the number of levels that are placed on the slide. I think what you would need to do though is be really careful at microtomy and kind of floating stage when you're putting your samples on the slide to make sure that they are not only inside the boundaries of your cover slip, but that they're also inside the boundaries of the scan region for the scanner that you would be using. And as much as possible, bring them close together, which I kind of touched on, is going to give you a smaller scan area, a smaller file size, and faster throughput overall for your scanners. So I wouldn't recommend necessarily changing away from some of the practices on how tissue is presented, but just are there steps that can be done to optimize those processes?
Next question. Can the system read slides? I mean, after scanning the slide, an H&E stained slide, will the AI tell if the tissue is normal or pathologic?
Um, Again, great question. And this is really where we see an awful lot of research and development and innovation around this space, both with H&E slides and then across a range of stains, and both for clinical or research applications. Um, there's no kind of silver bullet or magic app out there that is doing this. And for some of the products that have been released to market already, they're done on a kind of subspecialty or tissue based um, system at the moment, as opposed to any tissue on any slide in any lab being put through it and saying, is it normal or is it a tumor? But it's a massively accelerating area at the moment with so much focus and interest. There's a lot of indications that this is the direction that the technology is moving.
Great. Thank you. Our next question is there a difference using glass and plastic tape cover slips?
I think I would probably look at this in a similar way to the question about cytology and fluorescence, um, which is check your slides out with the scanner you're considering using. Um, Different scanners employ different focus mechanisms and tissue detection mechanisms. So you need to ensure that the scanner will work with your samples as they're created, whether that's using glass or plastic cover slipping. It's also going to depend on the glass and the tape cover slips that you're looking at using and the specific optical properties of those. Um, and also maybe the magnification that you're looking to scan at. There can be differences in the use of glass and tape at different magnifications. But for the most part, let's say my recommendation would be try it out with your samples and the scanner you're interested in. And then if it doesn't work, consider the part that you would like to change. Is it easier to choose a different scanner, or is it easier to change your cover slipping mechanism and to maybe be open to multiple ways to solve that problem if it occurs?
All right. Thank you. Next question. Is there anything we can do to color correct to have more consistency with glass between slides?
I'm not sure I fully understand that question. If we're looking at the actual glass color from a almost background perspective, or if it's standardization of the color with the slide. So maybe I'll try and address this in two different ways. I think that the first is if it's specifically on the color of the glass, sometimes these can have a slightly green tint or other kind of very slight color tints to the glass. And then if you're looking to standardize on that part, I think it'd be interesting to look at some of the functionality within different scanners that will white balance. So detect a piece on the slide where there is no tissue or no sample, um, and look to white balance on that. So effectively normalize on your color profile in that way. I think if the question was more in relation to the consistency of staining between slides, I think with that then is where possible, avoid manual staining, where you're doing manual dilutions of your stains. Look at your kind of ready to use um, type reagents where possible, and automation. I think the more we can look at bringing in automation into our processes, the more we can drive standardization and remove any kind of manual errors that are just inherently prone to manual processes.
All right, thank you. Next question. If there is a small artifact above the tissue after cover slipping, does all of the tissue on the digital image appear blurry, or does this just cause a few areas of blurriness around the artifact? Does the scanner see the artifact in the only scanned focal plane, or does it take more than one focal plane to complete the slide scan?
That is a great question. Um, and again, it's one that doesn't necessarily have a straight yes or no answer. Um, so this is really going to be dependent on the scanner and the scanner mechanism. So some scanners will employ a technique where they lay down a focus map first, so they will automatically detect um, where your tissue is, and then they will lay focus points on top of that tissue to kind of map that microtopography across the tissue and be able to then have a scan map that it follows. So if one of those scan points happens to be on a piece of debris or artifact, yes, it can throw out the scan map, and that could be the amount of blurriness in that image would be dependent on the size of the artifact and kind of where that next focal point or focus point is within the tissue. Other scanners will do a type of real-time focusing or dynamic focusing, where literally at every single almost frame that's captured, they're adjusting the focus. So you'll probably see less of an impact of debris in that situation. But again, if the debris is at a different focal plane and it's more prominent than the tissue, then if it's recognized as tissue and it's focused on, then it will put the underlying tissue out of focus. The other type is where you've got a 2D image capture rather than a line scanner. And quite often they will focus again for every 2D frame, kind of an XY section. And again, depending on how many frames that piece of debris would overlap into, would determine how much or if any of that image is out of focus. So I hope that helps to at least provide some guidance.
Great, thank you. Next question. You mentioned single focus plan is adequate for 3 to 4 micrometers HE stained sections. How about for 3 to 4 micrometer sections for fish, the same single focus plan, or need to use Z stacks? Interval 1 or 2 micrometer?
Okay, I think a great question. Again, it's going to depend a little bit on the magnification and the numerical aperture for the objective lens that you're using to scan. So typically speaking, and again, kind of as a broad spectrum rule of thumb, if you're capturing at an equivalent of a 20 times or 40 times magnification, then you should be able to capture in a single focal plane at 3 or 4 microns. If you go above that from a magnification perspective and you're in that kind of 60x, 100x, or 80 or 100 oil type scenario, then you probably need to move to Z stacks, and yeah, that interval of 1 to 2 microns. I think when you're adopting digital pathology and when you're looking at specific use cases, and I didn't really touch on this during the presentation, but it raises a very good point, which will be to actually look at your sample types that you typically have within your lab and work out what the scanning mechanism, what would the standard scanning process be for those slides. So it'd be something to take into careful consideration. And then if you're looking at fish and you're looking at multiple fluorophores within that tissue and you're potentially looking at multiple Z stacks, that's obviously going to give you a multiplier on the scan time and the file size that you have in that situation. And it's important then, as you maybe consider adopting digital pathology, that you take some of these things into consideration because they're going to impact on the throughput of your scanner and the amount of slides that you could typically scan within a normal day or a normal shift.
Right.
I hope that helps.
Great. Thank you. Next question. What would you recommend for control slides when you have multiple cases attached to one control?
That's an interesting one. So it's going to depend a little bit on the image management and image viewing system that you use, and can that control slide be kind of pinned or identified and associated then with your different, whether they're dosage groups or kind of reference slides maybe is a better term to use. So it's going to depend more on the image management system that you have there, um, and how your slides are aggregated into cases or groups or studies, depending on what you're looking at. And I think for that, there's probably some kind of clever identification that you could use within the barcode to identify those groups and then ensure that your control slide is always displayed in your slide view or your slide tray or grouping that you have for all of the dosage groups then that would be associated with.
All right. And it looks like we have time for one more question. Ideally, slides would come right off the cover slip and directly onto the scanner. Is this going to be possible, or what is the minimum amount of drying in oven for X minutes to minimize this time so that images are available ASAP?
Well, I can see that this question came in from Robert, and Robert, that's a great question. There are solutions on the market today where you have your stainer and cover slipper integrated, and then the stainers have integrated drying ovens on them. Um, and they take as little as 5 minutes for fully drying your cover slips. And then they're already in a rack that's compatible with scanners. In which case, then you're just taking a rack out of a scanner or out of a cover slipper and popping it straight into a scanner. Again, what I would recommend in this is to take that full holistic look at your laboratory if you're considering adopting digital pathology and identify which are the pieces that you're keeping and which are the pieces where you are open to change or optimization. And if that is at your staining or your cover slipping stage and you're going to be able to have a maximized efficiency or optimized efficiency at that point and remove some of that hands-on time, it may be a consideration where you want to ensure that your cover slipper rack and functionality, including the drying, is compatible with your scanner of choice.
And we will wrap up with that final question. Thank
Oh,
you again, Olga, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Leica Biosystems, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Goodbye.